in this question we're asked to express 4 over 1 plus 3x multiplied by 1 plus x all squared in partial fractions. So firstly we need to remember what form these partial fractions take. And in the previous video we discussed that this would take the form a over 1 plus 3x, but then we have the repeated factor of 1 plus x. So we have b over 1 plus x, and then we have c over 1 plus x all squared. And then by making a common denominator, this first fraction needs to be multiplied by 1 plus x all squared on the numerator and denominator. So we get a lots of 1 plus x all squared. The second fraction needs to be multiplied by 1 plus 3x and 1 plus x on the numerator and denominator. And the third fraction needs to be multiplied by 1 plus 3x on the numerator and denominator. And all of these would have a denominator of 1 plus 3x over 1 plus x all squared. Well, as this is an identity and is always true for all values of x, it must also then be the case that the numerators are identical. So we know that 4 must be identical to a lots of 1 plus x all squared plus b lots of 1 plus 3x 1 plus x plus c lots of 1 plus 3x. And this must be true for all x. So in particular, we want to pick a nice value of x that makes some of these brackets equal to 0. So notice here and here, if x equals to negative 1, both of these two terms would be 0. So if we let x equal negative 1, we get 4 is equal to 0 here, 0 here, and then we have minus 1 minus 3, so minus 2c, which therefore gives us that c is equal to negative 2. So now we need to think about what other values of x might be good. Well, notice that if x is negative a third, both of these two brackets are 0, so both of those terms would be 0. So letting x equal negative a third, we get 4 is equal to a lots of 1 plus negative a third, so 2/3 squared. So 2/3 squared is 4/9. The next two terms are 0, so 4 is equal to 4/9 of a. Well, that gives us that a is equal to 9. And then to find the value of b, we can either substitute in some other value of x, or we can equate coefficients. I'm going to equate the constant terms. So on the left-hand side, the constant term is 4. On the right-hand side, well, we would get a 1 by expanding out here. We'd multiply that by a, so we get a constant term of a. Here again, the constant term is just going to come from 1 times 1. That's going to be multiplied by b, so it's going to be positive b. And the constant term here is c times 1, so c. But we know the values of a and c, so we get 4 is equal to 9 plus b minus 2. And therefore we get that b is equal to negative 3. So we can conclude that 4 over 1 plus 3x, 1 plus x, all squared, is identical to a is 9, so 9 over 1 plus 3x. B is negative 3, so minus 3 over 1 plus x. And c is negative 2, so minus 2 over 1 plus x, all squared. And we've expressed this in partial fractions.